To find the domain of a relation, you're looking for the allowable inputs that you can have for that relation. So if you remember, the inputs are actually the x values. And by finding the x values, we'll be able to find the domain. In order to figure out which x values we have on these particular points, we can go ahead and label all of the points that are on this graph. So we can start by going ahead and taking this point, this one, and this one, and just labeling each of their coordinates. And then you would be looking for the allowable input values or the x values of each of those coordinate pairs to create the domain of this relation. To find the average rate of change between a particular interval, you're really looking for the slope. That was another word that we used for slope. The definition off of your formula sheet from the end of course test says that the average rate of change is the change in the y value divided by the change in the x value for two distinct points on a graph. Points on a graph can also be represented with a table of values like you see here. So if we take a look at the difference between the y values that go to these points and then the difference between the x values of those points, you can use these values here. So the numbers came from the table. We're only looking from where x equals 11 to x equals 15. So if I come over here, I really only care about right here where x equals 11 and where x equals 15. So that's where the values that you see are coming from. The outputs are right here, 3 and negative 18. And the inputs are over here. X is 11 and 15, just like the interval of the problem asked us to look for. And so then what you would do from this point is just continue working through your slope formula right here to compute the average rate of change or slope between the interval x equals 11 to x equals 15. You'll do your subtraction on top, negative 18 minus 13, and then your subtraction on the bottom, 15 minus 11. You can go ahead and simplify your answer as a decimal value. That would be fine. To simplify a fraction, you take the top number, divide by the bottom number once you have this simplified. Jamie and Rachel both have a New Year's resolution to save money. Jamie starts with $50 in her bank account, and each week she adds $10. Rachel starts with $35 in her account and adds $15 each week. How many weeks will it take before they have the same amount of money in their accounts? And you should be always using these properties of equality to justify the steps of your work. That's where you describe it. Did you add to both sides, subtract from both sides, divide on both sides, or multiply on both sides to solve the equation? So let's start by breaking down the information that's presented to us. I'm going to start here by underlining Jamie starts with $50 in her bank account, and each week she adds $10. If I want to represent that information, I can use the slope-intercept form to show my starting point and then how my amount of money is changing each week. So Jamie is starting with $50 and she's adding $10 per week. I'm going to let W stand for the number of weeks. And then we have some other information next in the problem. We've got Rachel, who starts with $35 in her account and adds $15 each week. If we follow a similar pattern to write an equation for that situation, Rachel's expression would look like this: $35 plus the $15 per week that she's adding. Now the question itself says, how many weeks will it take before they have the same amount of money in their accounts? This word same is what we're really looking for. When two things are the same, they are equal. So I want to set the two equations equal to each other. And then from here, you would use your properties of equality to move things from side to side and get the variable W all by itself. So for instance, if I were starting this problem, I would want to move the 10W to the other side of the equation to buddy up with our other W term. You want your numbers on one side, letters on the other, and you can do that by adding, subtracting, multiplying, and dividing on both sides of the equation. You always do the opposite of what you see. So for example, because I see plus 10W right here, if I wanted to move it to the other side, I would subtract 10W from both sides. So I'll go ahead and just do that first step of work to help get you started. You don't have to subtract 10W first. You could do something else, that's fine. I'm just showing you an example of a first step. Subtracting 10W from both sides of the equation would leave us with 50 equals 35 plus 5W. And now that you've got your variable terms all together, you would want to move the 35 to the other side of the equation so that you have numbers on one side and letters on the other, and just continue solving in that manner. To write a function to represent the information in the table, we can use slope-intercept form. We have a bunch of points that serve a relationship. They make some sort of pattern when we plot them on a graph. Slope-intercept form works for our linear equations. F of x is equal to mx plus b, or we said y equals mx plus b. Your m value is your slope or rate of change, like we found on a previous slide. And your b value is called the y-intercept. It's also your starting point, your initial value. It's the place where x equals 0. So you need to go find the slope and find the y-intercept in order to write a function. In order to find the slope, you're going to use any two rows on the table. It does not matter which two rows you pick. I don't care which two rows you pick. I chose these because I did. So you're going to use your slope formula to find the slope here. Your slope or your rate of change is the difference in the y values divided by the difference in the x values. So you're going to take the two y values that you selected and subtract them, and then take the two x values that you selected and subtract them. Just make sure that you're keeping them in the same order that they belong on the table. And then you would simplify this. So I would do 700 minus 500 to get my numerator, minus 550, I'm sorry. And then my denominator would be 6 minus 4, and I would simplify that to get my slope that would go in the place of this m value in my formula. Then to find the y-intercept, you're going to look for the place where x equals 0. A lot of times that is given to you. In this case, it is. Here's the row of the table where x equals 0, and you can see that the answer or the output is 250. So your y-intercept for this particular function is 250. You should have a plus 250 at the end of your equation because that value will go right here. To write an arithmetic sequence in function notation, you do it the same way that you did it when we learned about the functions in the first place. When you take these sequences, you are given formulas on your end of course test. You can use these formulas, but these formulas are given to you in something called sequence notation. That's where we use the A's and the N's and then the D for common difference. When you swap it over into function notation, the only thing that changes is that instead of using A's and N's, you're going to use F and X. You're just using that function notation that we've learned about all year. We're going to start by doing this first example. In order to write the explicit formula, I'm going to go check and see what I need. The explicit formula says that I need the first term, A1, and I also need D, the common difference. You could also jump down here and take a look at the function notation one that I've written on the board. You need f of 1. It just means you need your answer when x equals 1. You need your first term, and you also need D, that common difference. So I'm going to say that my common difference is going to be equal to however my values are changing as we move down the list. To go from 28 to 38 to 48 to 58 to 68, I am adding 10, so my common difference is positive 10. And then my first value in the list is 28. So if I take these numbers and I plug them into the formula that I see, I'm going to use this one right here. I'm going to say f of x equals 28 plus x minus 1 times 10. And now what you need to do from here is not turn this in as you see it. You need to simplify this equation. You would use the distributive property to multiply the x and the negative 1 by 10, and then simplify your terms. You should have some like terms to combine once you get this multiplied out. And then you would submit that as your answer to this one. You'll work out the second one in a very similar manner. You need to go find your common difference, figure out what you are adding or subtracting as you move down the list, and then also provide that A1 or F of 1, the first term that you see. The first term that you see should be 35. And you will fill in those two pieces, the D for common difference and the F of 1 or A1 for the first term. You'll go fill those into this explicit formula and simplify it as much as you can.